Today we're going to be looking at different types of graphs. Now, yesterday's lesson, or the previous lesson, if it wasn't yesterday, we already saw a couple of these standard looking graphs. One of them looked like this. It had a vertical and a horizontal asymptote, and then some corner curves like so. The other one had also a vertical and horizontal asymptote, but their corner curves were both on the top. Today we're going to add to those two more. The other two standard rational graphs look like this. They have two vertical asymptotes and one horizontal. One of them looks like this. It does have corner curves in the upper left and upper right, and then kind of a U shape upside down there. The other one, again, has two vertical asymptotes and one horizontal. This time the U shape is up here and the corner curves are down there. So all of the functions that we're going to be looking at today on the lesson and on the assignment fit into one of these four standard models. Not standards, standard models. These are the four right here, 1, 2, 3, 4, except for number 52. Number 52 does not look like any of these four, so you'll have to plot some points, plug x values into the function, get a y value, take that point and plot it to see what the curves are doing after you find your asymptotes. There is a 6-step process to finding these. We're going to first find the y-intercept, any x-intercepts, the vertical and horizontal asymptotes, and then from that we're going to try to figure out which category it might fall into and then make our graph. So let's start with the first graph. Number 1. The first thing we're going to do is find any y-intercepts. Well, functions only have one y-intercept, and that comes from placing a 0 where the x values are. So if we have 3 times 0 over 0 minus 2, that would be 0 divided by negative 2, or 0. So we do have a y-intercept that exists at 0, 0, the origin. Let's see if we have any x-intercepts. Don't know if I have one or many, so how do I find the x-intercepts? Well, I put a 0 where the y is. The y value is the same as f of x, so the 0 goes there. Now I'm going to basically multiply both sides by x minus 2. The other way to do this would be to cross multiply, but anyway, over here you'd multiply 0 times this. Well, 0 times anything is just 0. Here the x minus 2 binomials would cancel and you'd just get 3x. And of course, dividing both sides by 3, you'd get x equals 0. Now, that's not very helpful because we already know that there's an x-intercept at 0, because we had a y-intercept at the origin. It gave us basically 2 intercepts in 1. Okay, well, the next thing we need to find is any vertical asymptotes. Remember, today sometimes we'll have 2 of these. So 1 or 2. Let's see what we get. Vertical asymptotes come from looking at the denominator and making sure, first of all, that that doesn't cancel in the numerator, because if it does, then it doesn't give you an asymptote, it gets through the hole in the graph. Well, this one does not, so good. X minus 2 in the denominator, if we make a statement that that cannot be equal to 0, which is true, you can't divide by 0, then that'll help us find our vertical asymptote. Obviously, we're just going to add 2 on both sides, and we have the new statement, x cannot be 2. So if x cannot be 2, over here on our graph, that must mean that there must be this little invisible line that the graph cannot cross through, called our vertical asymptote at 2. Horizontal asymptotes fall into one of 3 categories. Again, we learned this on a previous lesson day. A horizontal asymptote either has a degree of the top that's less than the bottom, a degree of the top that's equal to the bottom, or a degree of the top expression that's larger than the bottom. So this, as you can see, 3x is a first degree expression on the top, and x minus 2 is also a first degree expression on the bottom. So since these are equal in degree, that means obviously the top is equal in degree to the bottom. So when that is the case, we find the horizontal asymptote, which is the line y equals some number. That's a horizontal line. By finding the coefficients in front of our leading terms and making a fraction of them. So we're going to take 3 and divide it by 1. So yes, we have a horizontal asymptote. It exists at y equals 3. So the question is, which of our 4 categories does this graph fall into? Well, we have enough information, we have enough clues to answer that question. If we go back to the first page, you can see that we only have 2 asymptotes, one horizontal and one vertical, and we have some part of the graph that exists down here in the lower lower left section. So, which one is it? Well, obviously not those 2. These have 2 vertical asymptotes. So, is it these down up here? Sure. Well, because we do have something down here in the bottom left and not here, so it's got to look like this. So, just in general, this is just a rough sketch of the graph. I know that it basically, generally, looks like this. And that's all we're going to do today. Just make some general sketches from standard models. Number 2, again, we start with the same process. First, we're going to find the y-intercept. You start by putting a 0 value in every place for x. So again, we're taking 0 on the top, dividing by -9, which gives you 0. So again, like example 1, we have a y-intercept at the origin. Finding any x-intercepts can be found by putting a 0 in for y, which is f of x. And then we multiply both sides by x minus 9. Cancels over here, giving us 2x squared. Here, 0 times anything is 0. If we divide by 2, we still get 0. If we take the square root of 0, we still get 0. So, again, not very helpful. We still have an x-intercept at 0, but that's what we already have. On your assignment, you'll find x-intercepts that are not just 0. All right, step 3 is finding any vertical asymptotes that we have. Remember, we could have 2. We do that by looking at the denominator and saying, hey, denominators of fractions cannot be equal to 0. Solving this by adding 9 to both sides and then taking the square root of both sides, don't forget your plus or minus here, gives you 2 vertical asymptotes, one at +3 and one at -3. Okay, how about horizontal asymptotes? Well, this falls into that second category, just like example 1, where the top degree equals the bottom degree. And so we take the fraction of the coefficients. The leading coefficient here is 2, the leading coefficient there is 1. So the horizontal asymptote exists at the position y equals 2. So what category of graph does this fall into? Well, it's got to be this one, because there is a point down here that can be mapped out. You see here on this one, there's nothing there. So there is my curve. And don't forget number 52, you'll have to plot some points and figure out what the curves are doing, because it doesn't match a normal model.